I'm analyzing how well a model distinguishes between two classes, like spam, not spam. This is a common task in machine learning. This is a table summarizing the performance of a binary classification model. It shows key metrics for each class and the overall accuracy. This refers to a measurement used to evaluate how well the model performs. Precision, recall, F1 score, and accuracy are examples. This is one of the two categories the model predicts. For example, in a spam filter, this could represent, not spam. This is the other category the model predicts. In a spam filter, this would be, spam. I measure precision by calculating the proportion of correctly predicted positive identifications out of all predicted positive identifications. This is the precision for class 0. It means that 85% of the instances the model predicted as class 0 were actually class 0. This is the precision for class 1. 90% of the instances predicted as class 1 were correct. Recall is the proportion of correctly predicted positive instances to all actual positive instances. This is the recall for class 0. The model correctly identified 92% of the actual class 0 instances. This is the recall for class 1. It correctly identified 82% of the actual class 1 instances. The F1 score balances precision and recall. It's the harmonic mean of precision and recall. A higher F1 score indicates better overall performance. This is the F1 score for class 0. This is the F1 score for class 1. Support shows the number of instances in each class present in the dataset. There are 100 instances of class 0 in the dataset. There are 150 instances of class 1 in the dataset. It's time for a multiple-choice question to check your understanding of the classification report. Are you ready? I'm testing your ability to interpret the numbers in the classification report and draw correct conclusions. This statement is about comparing precision values for both classes. This statement is about comparing recall values for both classes. This statement is about comparing F1 scores for both classes. I'm analyzing how well a model predicts two outcomes, like whether an email is spam or not. This is a table summarizing the model's performance, showing precision, recall, F1 score, and accuracy. Precision tells you what proportion of your positive identifications were actually correct. For example, if you predict 10 emails are spam, and 8 actually are, your precision is 80%. For class 0, e.g., not spam, the model's precision is 85%. For class 1, e.g., spam, the model's precision is 90%. Recall tells you what proportion of actual positive cases your model correctly identified. If 10 emails are actually spam, and you correctly identify 8 of them, your recall is 80%. For class 0, the model's recall is 92%. For class 1, the model's recall is 82%. The F1 score balances precision and recall. It's the harmonic mean of the two. A higher F1 score indicates a better balance between precision and recall. The F1 score for class 0 is 0.88. The F1 score for class 1 is 0.86. Accuracy is the overall correctness of the model. It's the percentage of correctly classified instances. The model has an overall accuracy of 87%. This is a multiple-choice question testing understanding of the classification report. I need to choose all the statements that are correct based on the classification report values. This statement checks if the precision for class 1 is greater than the precision for class 0. This statement checks if the recall for class 0 is greater than the recall for class 1. This statement checks if the F1 score for class 0 is less than the F1 score for class 1. This statement checks if the overall accuracy of the model is 87%. I need to select all the true statements from the options given. I see a classification report summarizing a binary classification model's performance. It shows precision, recall, F1 score, and support for each class, 0 and 1, along with overall accuracy. Think of it as a model report card. This row gives the precision for each class. For class 0, the model's precision is 0.85, meaning 85% of the instances the model predicted as class 0 were actually class 0. Similarly, for class 1, the precision is 0.90, indicating 90% accuracy for the model's positive predictions. Pretty good. This row displays the recall for each class. For Class 0, the recall is 0.92, meaning the model correctly identified 92% of all actual Class 0 instances. For Class 1, the recall is 0.82, indicating the model found 82% of all true Class 1 instances. We want high recall to avoid missing positive cases. This line presents the F1 score, which balances precision and recall. It's the harmonic mean of precision and recall, giving a single metric to evaluate both. Class 0 has an F1 score of 0.88, and Class 1 has an F1 score of 0.86. A higher F1 score is better, indicating a better balance between precision and recall. This shows the overall accuracy of the model. In simple terms, it's the percentage of all predictions that were correct, regardless of the class. Here, the model had an accuracy of 87%, which means 87% of its predictions were correct. I'm analyzing how well a model separates two categories. Think of it like sorting emails into spam and not spam. This analysis helps us understand the model's performance. I'm looking at a summary that shows how accurate the model is at classifying items. It gives me specific numbers to understand its strengths and weaknesses. The report shows precision and recall for two classes. Precision is about how many of the items the model predicted as that class were actually that class. Recall is about how many of the actual items of that class the model found. It is a multiple-choice quiz to check my understanding of the classification report. I need to pick the right answers based on the numbers provided. I need to decide whether statements about the model's performance are correct or incorrect based on the classification report numbers. I will check each statement carefully. Statement A checks if Class 1 has a higher precision compared to Class 0. I need to see which class has a larger precision score from the report. Statement B checks if Class 0 has a higher recall than Class 1. I'm looking for which class has the better recall rate. Statement C checks the comparison of F1 scores between the two classes. The F1 score is the harmonic mean of precision and recall, giving a balanced view of performance. Statement D checks the overall accuracy of the model. I need to confirm the total accuracy rate from the report. This table summarizes the performance of a binary classification model. I'll break down each metric. Precision measures how accurate the model's positive predictions are. For Class 0, the model's positive predictions are 85% accurate. For Class 1, that accuracy jumps to 90%. Higher precision for Class 1. Recall tells you how many of the actual positive cases the model correctly identifies. For Class 0, the model correctly identifies 92% of the positive instances. For Class 1, it's 82%. Notice that Class 0 has higher recall. The F1 score balances precision and recall. It's the harmonic mean of precision and recall. Here, Class 0 has a slightly higher F1 score than Class 1. 0.88 vs 0.86. Accuracy is the overall correctness of the model's predictions. This model is 87% accurate overall. That's a pretty good accuracy. I'm analyzing a classification report, a table that summarizes how well a binary classification model performs. Think of it as a report card for your model. It shows key metrics that help you understand its strengths and weaknesses. I'm asking you to identify which statements are true based on the classification report I'll show you. It's a multiple-choice question, testing your understanding of the metrics displayed. This statement is about the overall accuracy. Accuracy is simply the percentage of correctly classified instances. The report shows the model is 87% accurate, which means it correctly classified 87 out of 100 instances. That's pretty good. Precision tells us how many of the model's positive predictions were actually correct. The report indicates the model has higher precision for Class 1, 0.90, than Class 0, 0.85. In other words, when the model predicted Class 1, it was correct more often than when it predicted Class 0. Recall measures how many of the actual positive instances the model correctly identified. The report shows Class 0 has higher recall, 0.92, than Class 1, 0.82. This means the model was better at identifying all instances of Class 0 than Class 1. The F1 score balances precision and recall, giving a single metric summarizing the model's performance. It's the harmonic mean of precision and recall. The report shows that Class 0 has a higher F1 score, 0.88, than Class 1, 0.86. I see the precision for class 0 is 0.85, meaning 85% of the times the model predicted class 0, it was correct. The recall for class 0 is 0.92, indicating the model correctly identified 92% of the actual class 0 instances. Similarly, for class 1, the precision is 0.90, 90% accuracy in predicting class 1, and the recall is 0.82. The model found 82% of actual class 1 instances. Let's analyze the classification report and determine which statements are true based on the precision, recall, F1 score, and accuracy values. This statement checks if the precision for class 1, 0.90, is greater than the precision for class 0, 0.85. This compares the recall values for class 0, 0.92, and class 1, 0.82. Here, we will check whether the F1 score for class 0 is less than the F1 score for class 1. This statement verifies the overall accuracy of the model. We'll see if it matches the reported accuracy. Let's dive into these details. Sklearn classification_report provides a summary of a binary classification model's performance. We are analyzing its precision, recall, F1 score, and overall accuracy. This is an important evaluation step for any classification model. This is a table that shows the model's performance metrics, broken down for each class and overall. It's like a report card for your model. It is very helpful to analyze model performance.